Hi, so in this notes, this is the 11.5 box plot, supplemental notes. What does a box plot tell you about a data set? So we're going to be talking about the measure of variability. So in our previous lesson, we talked about the measure of center. So this has to do with the spread of the data. So not the center, but how spread out it is. So there are two types of spread data or variability data. There's range, which is the difference between the greatest and the least data value. It tells you how spread out the data is. And then the interquartile range, which we will be using the shortened version IQR. It is the difference between the upper and lower quartiles, and I'll show you what I mean by that in this example. So it says the data set below represents the total number of home runs that a baseball player hits each season for 11 seasons of play. What is the range in the interquartile range of the data? So let's first, in order to find our range and interquartile range, we should list our data in order from least to greatest. So our lowest number is 14. Then we have 15. Again, you can mark these off as you use them. It really helps out. 16. And then 19. There's no 20, 21, 22, 25, 27, 28, 30, and 32. So if we were finding the range, we would take our data, our highest data point, which is 32, and we would subtract our lowest data point, which is 14. And our range would be 18. But our interquartile range, or IQR, we have to do a little bit more. So what we're first going to do is find the median. So I am going to find my median by underlining and finding the middle term. So there, underline 1, 1. So our median is 22. Then it says that we need to find the upper and lower quartiles. So we are going to basically find the median of the upper portion of our median above the median and the lower portion of the median. So I'm basically going to find the median again of the two other points. So I'm going to find the median of the bottom, which is 16. So this is going to be our lower quartile, or LQ. Then I'm going to do the same thing on the other side. Let's just do yellow, which is 28. This is going to be our upper quartile. Then we're going to take our upper quartile and we're going to subtract our lower quartile. So I'm going to take 28 and we are going to subtract 16. And that is going to give me 12. So the IQR, I don't know why that's a 4, the interquartile range, is a better representation of the data, especially if the data has a outlier, something that skews the data. So an outlier is defined as any point or any data point that is greater than the upper quartile by more than 1.5 times the quartile range, or less than 1.5 or less than the lower quartile by more than 1.5 times the internal quartile range. All right, so what does that mean? So that means that we would take our lower quartile, our first quartile, so our 1 here, this would be 16, and we would subtract 1.5 minus our IQR, which would have been 12 in this example. And then here, and if the value is less than that, then it's an outlier. If the data, if we are going to do the same thing, take our upper quartile here, 28, add 1.5 times IQR, and if it's more than that, then it's a outlier. So let's determine if the data set has an outlier. Okay, so this is already in order for us, so that's nice. We are going to find our median. Okay, so we have 1 here. 26. I thought underlining would be easier, or highlighting. But it's not. Okay, so our median is 14. And let's find our upper and lower. Okay, so it's in between 9 and 11, which would be 10. We can take those two up and divide them, add the 2 up and divide by 2. And then if we do this side, we have 16 and 16, which is just 16. So this is going to be my lower quartile and my upper quartile, or Q1 and Q3. We'll be talking more about that in just a minute. All right, so finding our, if something is a outlier, we're going to take our quartile 1 and we are going to subtract, so which our quartile 1 is 10. We are going to subtract 1.5 times the IQR. So I need to find my IQR. So 16 minus 10 is 6. So my IQR is 6. So, which when I multiply that, I get 1.5 times 6 is 9. So 10 minus 9 is 1. Are any of our data less than 1? No. So far we have no outliers. Now we need to do the same thing with our quartile 3 information. So I'm going to take 16 minus 1.5 times 6, which is 16 minus 6, which is going to give me, or 16 minus 9, or at plus 9, I'm sorry. Which is 25. And 26 is greater than 25, so my outlier is 26. Let's try this again. All right, so this data is not in order, so I need to put it in order. So I'm going to have 1, it's probably easier for me just to type it in. All right, so we have 1, 3, 17, 18, 19, 21, 25, 26, 30, 48, and 50. Okay, so now let's find our median, which is 21. Then our lower quartile, which is 17. So this will be our Q1. Then do the same thing for our upper, which is 30. So this will be Q3. Okay, so now that we have our Q1, our Q3, let's find our IQR. So 30 minus 17, so our IQR is going to be 30 minus 17, which is 13. All right, so now that I have my IQR, I can do my first quartile. So I'm going to take 17 and subtract 1.5 times 13. Well, 1.5 times 13 is 19.5. So 17 minus 19.5 is negative 2.5. None of my data is less than negative 2.5. So there are no outliers that are in the lower portion of my data, but there might be some on the upper portion. So let's do our quartile 3 information. So I'm going to take 30. I'm going to add 1.5 times 13, which again, 1.5 times 13 is 19.5. So 30 plus 19.5 is 49.5. Is there data that is greater than 49.5? Yes, 50. So 50 is my outlier. All right, so that is how we determine an outlier. So all of this information is going to be useful when we're making box and whisker plots. So what we need to do, we need to find the mean. We need to find the mean of the data above the mean. So that's our upper quartile, which we did beforehand, and our lower quartile. Then we are going to find the largest and smallest numbers in the data set, which is going to be our upper extreme and our lower extreme. Then we're going to draw a number line with the appropriate scale to include all of the data. Draw a box with the median and upper quartile and lower quartile, and then draw the whiskers with the upper and lower extremes. So let's try this one out down here below. So we are going to first find our median, which is our middle term. So my median here is 3. Now we're going to find our upper quartile and our lower quartile. So my upper quartile is 6. Then we're going to find our lower quartile, which is 1. All right, then I'm going to make a number line using the data that we have. Our lowest number is 0, so I'm going to start off with negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. All right, so our median is at 3. So what I like to do is draw a line at 3 up, like so. This is going to be our median. Then our upper quartile is 6. So I'm going to do the same thing. Draw another line, and this is going to be my upper quartile. Then at 1, draw another line. This is my lower quartile. And then we're going to make a box. Then I'm going to plot my upper and lower extremes. My highest number is a 9. Then you're going to draw a whisker. My lowest number is 0. Draw a whisker. All right. So earlier we talked about quartiles. So this first area is the first quartile, or quarter. So this is 1/4 of the data is in between 0 and 1. Then 1/4 of the data is in between 1 and 3. 1/4 of the data is in between 3 and 6. And 1/4 of the data is in between 6 and 9. Okay, so what are the effects of an outlier? An outlier is a value in a data set that varies significantly from the rest of the data. So if an outlier is included, the range is changed drastically. When the outlier is included, the box and whisker plot is longer than the box is shorter. The range is 24 books higher than the interquartile range is 3.5 books higher when the outlier is excluded. The outlier affects the range more than the interquartile range. All right, so an outlier drastically affects the range, but it doesn't affect the interquartile range as much. So if there is an outlier and it's asking which type of spread or which type of variability you should use, you should say the interquartile range. But if there is not an outlier, then you can use the regular range. Okay, so the data set below has an outlier. 2, 10, 10, 11, 11, 12, 12, 12, 13, 14, 14. So 2 would be our outlier. Which value is changed the most by removing the outlier? Okay, the range, the median, the lower quartile, the interquartile range. Well, we already talked about how range is changed the most when we remove an outlier. And in our previous lesson, we learned that the median doesn't change much. Okay, comparing box plots. You can use box and whisker plots to compare the center and spread of the data. Two students compare the scores on their math test. Their results on 9 tests are shown in the box plot below. Compare the box plots. Which statements are true? Select all that apply. Okay. So Ben has a smaller range of test scores. Okay, so Ben's range is from, let's say that's 96, 7, 8, 9, 99 to 80. Okay, so 99 minus 80 is 19. Well, Nita is from 100 to 83. So 100 minus 83. No, hers is a smaller range. So that's no. The lower quartile and upper quartile Nita's data are both higher than the lower quartile and upper quartile of Ben's. Okay, so no. Yes, her lower quartile is lower, so no. And her upper is lower. Okay, so no. The median of Nita's data is equal to the median of Ben's. Yes, they're both in the middle there. So, yes. Highest test score. Yeah, her highest test score is 100 when his is only 99. Ben's lowest score was equal to Nita's lowest score. No. Hey, if you have any questions on this lesson or the assignment or quiz, please email me or let me know.